Here we've got a chain rule problem using inverse tangent, or arctan as it's sometimes called. So 5 inverse tangent of e to the 3x is going to require that we use the chain rule, but you might not know the derivative of inverse tangent, so I've placed it over here. I'm going to use this as I tackle this derivative. So I'm going to get f prime of x equals, derivative of 5 tangent inverse would be 5 times 1 over 1 plus whatever this guy is squared. So e to the 3x goes in here, and then I square it, just using this rule over here. 1 over 1 plus whatever's inside this parentheses being squared. The chain rule kicks in and says you've got to take the derivative of this inside function. So inside inverse tangent is e to the 3x. Its derivative is e to the 3x. And what about the inside of e? Well, e also has an inside function. So inside the arctangent was the e to the 3x, and inside the e to the 3x, there's a 3x. So we've got to take the derivative of this inside function. The derivative of 3x is just 3. So I want to kind of back up a little for a second and say tangent inverse had e to the 3x inside it, so we have to use chain rule to take its derivative. There's 3x inside the exponent of e, so we have to use the chain rule again to take that derivative. So there's a chain rule there and a chain rule here as well for a total of 2 chains. Okay, now let's clean this up a little bit. We can do a little bit of simplification. 3 times 5 is 15. And we have an e to the 3x that also sits in the numerator, all divided by 1 plus e to the 3x squared. When you square, or when you do power to a power, when you're doing exponents, you multiply those powers. So 3x times 2 is 6x, and that gives us e to the 6x for our final answer.